morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Ubinda with another video. So we are continuing on calculus. This is differentiation. We are looking at the second differential coefficient, practice question 2. The main essence of practice questions is for you to practice first. Then after you practice, you can compare the answers you find with the solutions I'll provide in this video. Let's get on with the answering. So for question A, we have x to the power 4 minus x squared minus 1 over x squared. So say y is equal to x to the power 4 minus x squared minus x. If we take this x squared up, it's going to have a negative exponent minus x to the power negative 2. So to differentiate, we'll say dy x is equal to 4x to the power 3 minus 2x, like that. Then plus 2x to the power. Negative 2 minus 1 is going to be negative 3. So our dy x is going to be equal to 4x to the power 3. And then plus a 2 over x to the power 3 minus a 2x. I've just changed the order of these two here. It doesn't really matter. You can write this at the end. You would still be marked. So this is your final answer. 4x to the power 3 plus a 2 divided by x cubed minus 2x. Okay, then the next part of the question is we need to find the 2y dx2. Okay, the 2y dx2 is going to be equal to, differentiate this answer here, which is your dy dx. You're going to have 12x squared minus 2, then here minus 6, okay? And then we maintain the x, raise the power negative 4. So the 2y dx2 will therefore be equal to 12x squared minus 2 minus 6 divided by x to the power 4 as your final answer. Alright, so that's your final answer. I wanted to write it in descending order, the powers in descending order, but even writing it in this form is okay. As you can see, we are done with question A. So let's go to question B. Question B is 1 you divide by x. So you say y is equal to x to the power negative 1. dy x is going to be equal to negative 1 raised to the power negative 2. Okay, if you know how to do the chain rule. So this is your dy dx. And then they want us to find the 2y dx2, right? The 2y x2, which is equal to a positive 2 x to the power negative 3. So you can leave your answer like this, but it's best to leave it like negative 1 divided by x squared. So you can leave your answer like this. This is the best way to leave it. Okay? And then this one is going to be equal to 2 divided by x to the power positive 3. This is your dy dx on top here, then this is your d2y dx2. Alright, so we are done with B. Then we're going to go to C. C is x squared minus 1 over x. So y is equal to x squared minus x to the power negative 1. Since the x has gone up, the power now become a negative. So to find our dy, x is going to be equal to 2x plus 1, okay? Okay, 2x, like that. Then it's going to be a plus x raised to the power negative 2. Then our dy x will therefore be equal to 2x plus a 1 over x squared as your final answer. So that's your dy dx. Then to find our second derivative, what we'll do is we'll say the 2y dx2 is equal to, we differentiate 2x, is going to be 2, okay? Okay, first of all, let's write our dy dx in a different form. dy dx is going to be equal to 2x plus x to the power negative 2, like that. Then our second derivative, which is our d2y dx2, is going to be equal to 2 minus, because of the negative 2 multiplied by the positive 1 in front, so minus 2 x to the power negative 3. So this will be equal to 2 minus 2 divided by x to the power 3, and that will be your final answer. Okay, so that's your answer for C. Let's quickly go to D. Okay, this is solutions. Let's quickly go to D. D is saying 3 you divide by 2 minus x, so you say y is equal to 3 multiplied by 2 minus x raised to the power negative 1. Then to differentiate it, you're going to say dy dx is equal to negative 3 multiplied by 2 minus x raised to the power negative 2 multiplied by the derivative of the core, which is negative 1 in this case, and then our dy dx will therefore be equal to the positive 3 divided by 2 minus x raised to the power the positive 2 as your final answer for your dy dx. And then to find your d2y dx2, we start by writing the dy dx. dy dx is equal to 3, okay? You multiply by 2 minus x, which has to be raised to the power negative 2. So our d2y dx2 is going to be equal to negative 6 multiplied by 2 minus x raised to the power negative 3. Derivative of the core is a, as you can see in this case, negative 1. Okay, so therefore our d2y dx2 is going to be equal to a positive 6 divided by 2 minus x raised to the power positive 3 as our final answer. So this is the answer for dy dx, then that's the answer for the 2y dx2. Next question is E. So for E, we have 1 minus 4x raised to the power 4. So y is equal to 1 minus 4x raised to the power 4. So our dy dx is going to be equal to positive 4 multiplied by 1 minus 4x raised to the power 3 multiplied by the derivative of the core. In this case, it is a negative 4. So you're going to multiply these two numbers. You're going to have your dy dx to be equal to negative 16. You divide by 1 minus 4x. No, you don't divide, sorry for that. Negative 16, you multiply by 1 minus 4x raised to the power positive 3 as your dy dx. And then your d2y dx2 would be equal to 3 times negative 16. You're going to have negative 48 multiplied by the core. You're seeing that? So this is x raised to the power 3 minus 1 is going to be power 2 multiplied by the derivative of the core. In this particular case is a negative 4. So I'm going to clean up at the top, and then I'm going to simplify 48 times 4. This is a 32. 4 times 4 is a 16, so 192. So I'm going to get positive 192. So the 2y dx2 is going to be equal to 192 multiplied by 1 minus 4x raised to the power positive 2 as your final answer. So this is your dy dx, then that's your 2y dx2. And then for your E, yes, we have done our E, so going to our F. For our F, we have 2x minus 7 raised to the power of 3. So y is equal to 2x minus 7 raised to the power of 3. Then our dy, x is going to be equal to 3 multiplied by the function. So the derivative of this function there is looking, we'll drop the 3 multiplied by the number in front, will just be 3. Because the number in front is 1. The power there will lose 1 to become a 2. Then you multiply by the derivative of the core. In this case, it is a positive 2. So our dy x is going to be equal to a 6 multiplied by 2x minus 7 raised to the power 2. That's your final answer for your dy dx. And then to find out the 2y dx too, we differentiate our dy dx. Okay. So our d2y x2 is going to be equal to 12 multiplied by 2x minus 7. You see what I've done? So the power 2 multiplied by 6 will give you a 12, multiplied by the core will remain the same, and then the other of a power 1, we don't write the power 1. The derivative of the core is a positive 2. So your d2y dx2 is therefore going to be equal to 48 multiplied by 2 minus x, 2x minus 7. That's the final answer. So your 48 multiplied by your 2x minus 7 will be your final answer for the 2y dx2. And this marks the end of the video. You should stay until the end of this video. Thank you so much for watching. This video will truly benefit you. This has been Cornelia Subinda with another video, and bye bye.